Hello, ladies and gentlemen. Today we're going to look at graphing inverse trigonometric functions. And we're going to start by graphing the sine function first. All right, remember that the sine of negative 2 pi is 0. All right, the sine of negative 1.5 pi is positive 1. The sine of negative pi is 0. The sine of negative pi over 2 is negative 1. The sine of 0 is 0. The sine of pi over 2 is positive 1. The sine of pi is 0. And the sine of 1.5 pi or 3 pi over 2 is negative 1. All right. And then the sine of 2 pi is 0. So the graph for the sine would look a little bit like this right here. Excuse me, let me get this graph here. All right, and if you were trying to find the inverse, all right, it would have to pass the horizontal line test. Well, it fails the horizontal line test all the way across, all right? So what we want to do is we want to restrict the domain on the sine function so that it would pass the horizontal line test, and we can do that if we restrict it from here to there, all right? So in other words, from negative pi over 2 to positive pi over 2, all right? If we restrict the domain there, then it will pass the horizontal line test, all right? And it has to pass the horizontal line test or be 1-to-1 in order to have an inverse. All right. So if that's true, and what we can do is on the y-axis, we can put negative pi over 2 here, all right, and positive pi over 2 over there. We're going to exchange the y's with the x's, all right, because this is negative pi over 2, and that's positive pi over 2, all right. And that point is pi over 2, 1. This point is negative pi over 2, negative 1. And, of course, we have all the values in between. Okay, so if we're going to graph the inverse, we would start with this endpoint first, all right? And that would be negative 1, negative pi over 2, which would be this point, okay? And just so we have a little bit more points than just these three, all right, yeah, this is the origin. We know that it's going to stay there. And this one here would be 1 for the x-coordinate and pi over 2 here, but it's not a straight line, it's a curve. And to get the points that we need, let's take negative pi over 4, okay, all right, and positive, and get its coordinates. If x is negative pi over 4, then the cosine is negative pi over 4, then we get negative square root of 2 over 2, all right, which is about, what is that decimal? Let's see, negative square root of 2, let's see, the square root of 2, come out from under there, divide that by 2, a negative 0.7, okay? All right, so negative 0.7, and then negative pi over 4 would put it right down in here, okay? All right, and then positive 0.7, and excuse me, I would put it up in here. So that graph is going to come up through here, and then it's going to look like that right there. So there's the graph of f of x is equal to the inverse sine of x, okay? We also call that the arc sine of x, Now, notice that the domain of that function, all right, is from negative 1 inclusive up to positive 1, all right? And notice that the range of that function is from negative pi over 2 inclusive up to positive pi over 2. All right, so that's what we need to understand. And recall that the sine of t is the y-coordinate of the point on the unit circle corresponding to the angle or arc length t. Because the range of this inverse is restricted to negative pi over 2 to positive pi over 2, the possible angle measures of the inverse sine are located in the first quadrant and in the fourth quadrant. So all of your values that you get for the inverse trigonometric sine function, all right, will come out of those two quadrants. Now, your angle may be over here, and you may have to make adjustments for that, but that's what this means right here, is that all the inverse sines is defined only for angles that are in the first and fourth quadrant. Okay, now let's go look at the inverse cosine. We'll turn the page on our notes. Recall that, first of all, the cosine of negative 2 pi is 1, all right? And the cosine of negative 1.5 pi is 0, okay? And the cosine of negative pi is negative 1, all right? The cosine of negative pi over 2 is 0, all right? And, excuse me, the cosine of 0 is 1, all right? And the cosine of pi over 2 is 0, and the cosine of pi is negative 1, and the cosine of 1.5 pi or 3 pi over 2 is 0, and the cosine of 2 pi is positive 1. So that graph comes down through here, curves over like that, comes back up like that, comes down, comes over, comes up, goes over. Now, once again, the actual cosine function does not pass the horizontal line test. All right, so in order to get a portion of this graph that would pass the horizontal line test, we're going to have to restrict the domain. And a good part of the portion of that graph that we could do would be that part of it right there. All right, so in other words, if we start with this point 0, 1, and this right here, this point is pi over 2 for x, 0 for y, all right? And there's a point in between there. Half of that is pi over 4, all right? The cosine of pi over 4 is square root 2 over 2, or 0.7, okay? Over here, that's 3/4 of pi, okay? So that point has coordinates of 3 pi over 4, and y-coordinate of negative 2 over square root 2. And of course, this point down here is pi negative 1. Okay, all right, so we're going to do the inverse of that part of the cosine function, and we'll begin with negative 1 pi. So from x is negative 1, and pi is the y-coordinate, that's that point right there. Now we're going to take this point right here and invert it next. That's negative 0.7, which would be in here somewhere, and 3/4 of pi would be up about right in here somewhere, okay? And this point right here would be 0 pi over 2. If that's pi, pi over 2 would be right here, halfway, all right, between 0 and pi. All right, and then we're going to invert this. That's 0.7, and then pi over 4. Okay, pi over 4 would be about right there. And then when we do the inverse of this point, 1, 0, we get that point right there. So that graph will come down likewise, and then it'll curve over likewise. And that is y is equal to the inverse cosine of theta or x, whatever you want to call it. It is also called the arc cosine of x, or theta. All right, and the thing we need to realize is this. Recall that the cosine of t is the x-coordinate of the point on the unit circle corresponding to the angle or the arc length of t. Because the range, and we didn't do this, let's go back and talk about the range, all right? The domain of this function, all right, and we may want to come over here. The domain is the x-coordinates from negative 1 to positive 1, okay, inclusive. All right, and the range of this function is from 0 up to pi, inclusive. You do include both of those. Okay, all right. So recall, because the range of the inverse of cosine is restricted to 0 to pi, the values of the inverse cosine are located in the first and the second quadrants, which means if you do an inverse cosine, it will give you one of these angles from 0 over to pi, okay? So there's your first quadrant, there's your second. All right, let's turn the page. can talk about the tangent. Okay, all right. If we were to graph f of x is equal to the tangent of theta, so f of x is equal to the tangent of theta, all right? First of all, we know the tangent is undefined at pi over 2 and negative pi over 2, so there's where your vertical asymptotes are, okay? And if you recall, the tangent of negative pi is 0, all right? The tangent of negative 3 pi over 4, all right, is 1, and that graph comes over through there and approaches up through there. The tangent of 0 is 0, all right? The tangent of negative pi over 4 is negative 1, so it comes down through here. The tangent of pi over 4 is 1, all right? So that graph comes down through here, approaches the asymptote there, it goes over through there, approaches there. The tangent of pi is 0. The tangent of 3 pi over 4, positive 3 pi over 4, is negative 1. Whoops, not that point down here. So that graph comes down through here. There's what your tangent looks like. Notice that the domain for that tangent is, well, first of all, we're going to have to restrict that domain because if you try to perform the horizontal line test, it fails everywhere, all right? So what we're going to do is we're going to restrict that domain to just this part of the graph right here. So the restriction on that domain will be between those two right there, all right? So the domain we're going to restrict to just negative pi over 2, all right? And we're not going to include that because there's an asymptote over here all the way up to pi over 2. All right, and if you do that, then your range is all real numbers. Range is from negative infinity up to infinity. All right, and when you do an inverse, you exchange the domain with the range, okay? So our range over here is going to be from up here. In other words, those vertical asymptotes are going to be horizontal asymptotes is what's going to happen. And that's going to restrict your range, all right? So your range is going to be, all right, your range will be from negative pi over 2 up to pi over 2, okay? All right, and your domain will be all real numbers from negative infinity up to positive infinity. All right, and now if we take this point and switch them, you get that point, okay? All right, and if we did negative 1, okay, that was this point right here. This point right here was negative pi over 4 for the x-coordinate and negative 1, and if you switch those, all right, you would get negative pi over, negative 1, negative pi over 4. Well, that's right about here, okay? All right, and if you take this point, which was pi over 4, positive 1, all right, and invert that, you would get 1 pi over 4. So that graph is going to come off of here, come down through here, and approach that like that. It's going to do the same thing over there. It's going to look like that. Okay, so that is the graph of f of x is equal to the inverse tangent of x. All right, or you might call it the arc cosine. You may say f of x is equal to the arc tangent, the arc tangent of x, which is the inverse tangent of x. And notice that all of those, that range comes out of the first and the fourth quadrants, which means if you do an inverse tangent, all of your angles that you get will come out of the first or the fourth quadrant. All right, let's turn the page. The next part here says to sketch the graph of the inverse tangent of 2x, or excuse me, inverse sine of 2x, my fault. Okay, all right, so here's my y-axis, all right, and here's my x-axis, all right, and I'm going to graph the inverse sine of 2x. Well, that 2 is going to take the inverse sine parent function, and it's going to shrink it by a factor of 1/2. Well, if you remember just a moment ago when we did the inverse sine, all right, the inverse sine, okay, oops, I need the inverse sine. Let me pull that one out. The inverse sine all right, had a domain from -1 to +1. Well, we're going to change that to half, all right? So if this is -1 and that is -1/2, and if that's +1, then +1/2 would be here, all right? And it's going to, that's going to restrict that domain to just be from -1/2 to +1/2, okay? And the range is not going to change because there's no vertical change. So the range is going to be from pi/2. So if this is pi/2 would be right here. And if that's pi up there, negative pi would be down here. And negative pi/2 would be right here. So that range is going to stay between negative pi/2 and pi/2. So it's going to come from here, and it's going to go up like this, and it's going to go over to that point right there. So that's what that graph would look like, okay? All right. Next, let's do the arc cosine of x plus 3. Well, that would take your parent function, your cosine, inverse cosine parent function, and translate it, all right? That would translate it 3 units to the left, okay? All right, and here's the parent function itself. I'm going to put it back up here that we just wrote down. All right, so we're going to take that and move it 3 units to the left. Okay, well, if we're going to do that, I'm going to start with an x coordinate system here. All right, and I'm going to move the y coordinate. Let's do this. Let's go -4, -3, -2, -1, 0, 1. All right. And I'm going to put my y-axis right here. Okay, all right. Normally on the parent function, you've got, we need the y labeled as well. The y is not being altered at all right? So I'm just going to say, okay, this is pi, that's pi/2. This is negative pi/2, and that's negative pi, all right? And I know that each point on my parent function is basically going to move 3 units to the left. So if I take this point that was over there at 1, 0, and move it 1, 2, 3 to the left, it goes to -2, 0. All right? And the parent function goes through pi/2, 0 pi/2, excuse me. All right? And if I take that point and move it 1, 2, 3 to the left, it would be right there. Okay, and it also goes through -1 pi, which would be here, and if I move that 1, 2, 3 to the left, that would be at -4 pi. All right, so that graph comes down through here, all right, and then it comes over and goes like that right there. So there's what that graph would look like, all right. Now, let's go to number 3. Number 3 says to sketch the graph of y is equal to the inverse tangent of x plus pi/2. Well, that's a vertical translation, pi/2 units. All right, so I'm going to bring my tangent graph back. Let me get my tangent graph. Where did I put it? Oh, okay. Here's my inverse tangent graph right here. Okay, and what I'm going to do is I'm going to move this graph, all right, and I'm going to move it up a vertical translation of pi/2 units, okay? All right, so I'm going to first put my x-axis down here, my y-axis right here, x and y, and I'm going to move everything, I'm going to say, okay, all right, normally, if you look, the parent function has vertical or horizontal asymptotes at pi/2 and negative pi/2. But this is going to move those up, okay, pi/2 units, which really means that, I'm going to graph the parent function. Let me do that first. Okay, if I make this negative pi/2, okay, and this positive pi/2 right here, I'll graph the parent function, all right. The parent function would come over here like that and come down here like that. There's your parent function. And I'm going to do the translated graph pi/2 units. All right, this was negative pi/2, that was positive pi/2, and what's going to happen is this thing's going to go up pi/2 units. So now this horizontal asymptote is going to be here, so there's going to be that horizontal asymptote, and this one is going to go up pi/2 units, which would put it there, okay, at pi. All right, so this point right here would move to here. So that graph is going to come over and approach that one. It's going to come down here and approach there. And there is y is equal to the inverse tangent of x plus pi over 2. Okay, all right, now it's time to go and evaluate some of these inverse trigonometric functions. We want the inverse sine of 1/2. Now, the inverse sine is defined only in the first and fourth quadrant. So when we get an angle, we have to get one out of the first and fourth quadrant. Now, what this means is we go over to our unit circle and we find which angle has a sine that is equal to 1/2. Okay, well, the sine is positive over here, and there's the angle that has a positive 1/2 for the sine, so that would be the angle pi over 6. So the inverse sine of 1/2 is pi over 6. All right, let's go to number 5. Number 5, we want the inverse sine of the square root of 2 over 2. Well, we're going to get our angle here. Sine's y-coordinate is positive, and that means it's up here in the first quadrant. And the one that's square root of 2 over 2 is pi over 4. All right, so we'll go, and this would be pi divided by 4. All right, now let's go to the arc sine of 3. Well, we're looking for a sine, an angle whose sine is 3. Well, on the unit circle, you have the sines, just like the graph, fluctuate between -1 and 1, all right, unless there's been some kind of transformation, a stretch vertically, and there has not been. So we're going to say that this is not possible. All right. By the way, if you were to take your calculator and you did the inverse sine, I want to show you how to do that on your calculator, but I'm going to clear my RAM first because I got stuff in here I don't want, and I want to go into radian mode anyway. The inverse sine is second sine, and then you type in 3, you'll see that gives you an error. There's a domain error. That's not possible. Okay? By the way, if you want to check that first one, you could. I will tell you that as well. All right, if you do inverse sine of 0.5, that'll give you that decimal. That is the same thing as pi divided by 6, that decimal right there. So you can see how you did that. That's how you check it with the calculator. All right, next we're going to look at the arc sine of negative square root of 3 over 2. All right, that sine is negative. The sine value is negative square root of 3 down here. So that angle is negative 5. Negative, and really you're going to give the angle that this is, but negative pi over 3, that's what that is. That is negative pi over 3. Now you don't want to give 5 pi over 3 because that does not fall into the range of the inverse sine. Remember, the range of the inverse sine is from negative pi over 2 to positive pi over 2, and 5 pi over 3 does not fall into that range. So you have to use the angle, the reference angle in essence, okay? And just to show you that that works here, watch, I'm going to do the inverse sine, the inverse sine of negative the square root of 3. Be sure you come out from under that before you divide that by 2. It will come back and give you negative 1.047 . That is the same thing as negative pi divided by 3 completely across the board. And that is not the same thing as 5 pi divided by 3, as you can see, so be very careful. Okay, all right, next, number 8, we're going to find the inverse cosine of the square root of 3 over 2. Well, remember, the inverse cosine is defined in the first and second quadrant. And the cosine is the x-coordinate, and that's positive, so that's going to give us a first quadrant angle, so that helps you figure out where to look. So, and x is the cosine, so we're looking for square root of 3 over 2. There it is right there. There's the angle. That is pi over 6. Okay? Next, we're going to do the inverse cosine of 1. All right? Here's where the cosine is 1, and that's the only place on the unit circle for which the cosine is 1. And we need to give the answer that is between 0 and pi, inclusive, and that would be 0. All right. Let's turn the page. Let's next find the arc cosine of 2. Well, on the unit circle, is the cosine ever equal to 2? And the answer is no, it is not, because it always fluctuates between -1 and +1, so this is not possible. All right, let's go do the inverse tangent. That is the square root of 3, the inverse tangent of the square root of 3 over 3. And that's looking for the angle measure whose tangent is the square root of 3 over 3. Now, please recall that the inverse tangent is defined only in the first and fourth quadrants. So, and with the tangent's positive in the first, so that tells you need to look in the first quadrant and find the angle whose tangent is the square root of 3 over 3, and that is pi over 6. So this would be equal to pi over 6. Let's go to number 12. In number 12, we are looking for the arc tangent of 0. All right, so between negative pi over 2 and pi over 2, where is the tangent equal to 0? Well, that's right here at 0. All right, so that would be 0. Next, number 13, we want to find the arc tangent of negative square root of 3. Okay, or the angle whose tangent is the square root of 3. Well, that's positive, and that would put you in the first quadrant. The square root of 3 has, the tangent is equal to the square root of 3 at pi over 3. So this is pi over 3. All right, next we want to look at some compositions of some of these. All right, let's start with number 14 here. And number 14 says, what is the sign of the inverse sine of 1/4? Well, 1/4 is not a value on our unit circle. So what I'm going to do is this. I'm going to sketch a coordinate system, all right? And then I'm going to ask, where is, first of all, the inverse sine defined? First and fourth quadrants. And then next, I'm going to say, okay, where is the sine or the y-coordinate positive? That would be in the first quadrant. So I'm going to draw my angle over to the first quadrant, theta, if you like, because I don't know what it is. All right, and I'm going to drop a perpendicular from from the side, a point out on that terminal side, and that I now know I got a right triangle. And sine is the opposite leg, 1 divided by the hypotenuse. All right, and now what I want to do next is, that gives me theta, all right? So what I want to do now is to say, okay, I've got theta, it's this angle. I don't know the measure, but I've got it, it's down here. So now I want to do the sine of that theta. Well, the sine is the opposite leg divided by the hypotenuse, which is going to be 1/4, okay? All right, let's go to number 15. In number 15, we are doing the inverse cosine of the sine of 2/3 of pi. All right. Well, 2/3 of pi is right here. The sine of 2/3 of pi is the square root of 3 over 2. So this would be the same thing as the inverse cosine of the square root of 3 over 2. Now, inverse cosine is defined in the first and the second quadrant, and which one has a positive? Well, that's the first. So we're looking over here, and we're going to find the angle that has a cosine equal to square root of 3 over 2. Square root of 3 over 2 right here is pi over 6. So this is equal to pi over 6. All right, let's go down to number 16. In number 16, we want to find the cosine of the arctangent of -3/4. Okay, well, the arctangent or inverse tangent is defined in the first and the fourth quadrant. And that tangent is a negative value inside there. So we're going to find the angle. Oh, -3/4 is not on the unit circle, all right, because all we've got are these tangent values right here. So I'm going to sketch that angle, all right? I'm going to sketch that angle, all right? I know it's in the fourth quadrant down here, so there's theta, all right? And I'm going to drop a perpendicular. For this angle, I know that tangent is, excuse me, the opposite leg, I'm going to put the -3 over there, divided by the adjacent leg, 4. All right? And I want the cosine of this theta. See, here's the angle theta right here, formed by those two rays. And I want the cosine. Well, that means I need this hypotenuse because cosine is the adjacent leg divided by the hypotenuse. Well, 3, 4, oh, that's the Pythagorean triple, 3, 4, 5. And that means that the cosine is the adjacent leg 4 divided by the hypotenuse 5. So the cosine of the inverse tangent or arctangent of negative 3/4 is 4/5. And you could check that with your calculator, by the way. I will show you can do that. Okay, if you do cosine of inverse tangent of negative 0.75 or 3/4, same difference, close it off twice, it will come back and give you the same thing. Of course, now it gave it to you in decimal form, but you can convert it if you need to. And there you can see that we've done that correctly. It is indeed 4/5 or 8/10, however you wish to name it. Let's go to that next one. All right, in that next one, we're going to do the sine of the inverse tangent of 1 minus the inverse sine of 1. Okay, and you need to work from inside out. All right, so first thing I want to do is I'm going to leave that sine alone for a moment, and I'm going to find the inverse tangent of 1. Well, the inverse tangent is defined in the first and fourth quadrant, and it would be positive up here in the first quadrant, and the angle whose tangent is 1 is this angle pi over 4. So the inverse tangent of 1 is pi over 4 minus. Now we're going to do the inverse sine of 1. Remember, the inverse sine is defined in the first and fourth quadrants, and it would be positive up here where the signs are positive, not down here where they're negative. All right, so the sine of 1, oh, wait a minute, sine is the y-coordinate. Sine is 1 at pi over 2. So that would be equal to pi over 2. All right, in other words, the inverse sine of 1 is pi over 2. Well, that would give me the sine of, I need a common denominator so I can combine those two angles and subtract those two angles. That first, the common denominator would be 4. It's already 4 here, so I'm going to minus 2 pi over 4. This would be equal to the sine of, when we subtract, that's going to give us negative pi over 4. All right, and the sine of negative pi over 4, this is negative pi over 4. It's coterminal with 7 pi over 4. The sine would be negative the square root of 2 over 2. Okay, so this would be equal to negative the square root of 2 over 2. All right, so there's your answer for number 17. Let's go to number 18. In number 18, all right, we have, we're looking for the cotangent of the arcsine of x. Okay, well, I know that the arcsine or inverse sine is defined in the first and in the fourth quadrant. Okay, well, if it's x, that's positive, which means I'm going to draw it up into the first quadrant. I'm going to drop a perpendicular, okay, all right, and I'm going to say this is my angle theta here for a moment. If I know that the sine is x, I'm going to make that a fraction. That would tell me that the opposite leg is x and the hypotenuse would be 1. And now I want the cotangent. Well, the cotangent, remember, is the inverse of the tangent, all right? Which means that I want the tangent of this angle, okay? And the tangent would be the sine divided by the cosine. So I need, and really what I'm going to do is I'm going to do the cosine of theta divided by the sine of theta. That's how I will get my tangent, or my cotangent, excuse me. Okay, so the cosine, I'm going to have to find this adjacent leg here. All right, so this adjacent leg, let's call it A squared plus x squared would equal 1 squared. So a squared plus x squared would equal 1. So a squared would equal 1 minus x squared. Take the square root of each side. A would be equal to the square root of 1 minus x squared. Okay, all right. So, oh, wait a minute. or I can just do the tangent, reciprocal of the tangent. Let's do it either way. You can think of it either way. All right, that's what I'm going to do, the inverse of the tangent in order to get the cotangent. All right, so the cotangent of the arcsine of x would be equal to, all right, tangent is x divided by, opposite divided by the adjacent. The cotangent would be the adjacent, negative the square root of 1 over the opposite, which would be x, and there you go. There's your answer right there. So that would be the cotangent of the arcsine of x. All right, next we're going to find the cosecant of the inverse cosine of x. Well, the inverse cosine is defined in the first and the second quadrants, okay? So if it's positive in the first, so this angle, I'm going to sketch it over into the first. There's the theta that we're talking about that has a cosine of x. Well, if we make x a fraction, cosine would be the adjacent leg divided by 1, all right? And now I'm going to find that, that other leg over there because I want the cosecant, which is the reciprocal of the sine. So I'm going to find the sine and reciprocate it, okay? All right, so cosine. Well, I've got the cosine. I'm going to use that. So let's say this is a. So a squared plus x squared would equal 1 squared. So a squared plus x squared would equal 1. All right, so a squared would be 1 minus x squared. Take the square root of each side. A would be the square root of 1 minus x squared. All right, so that's that missing leg length over there, okay? And if I want the cosecant of this angle theta here, the cosecant would be equal to the reciprocal of the sine. Well, the sine is opposite divided by hypotenuse. So if I reciprocate that, that would be hypotenuse, 1, divided by the opposite leg, the square root of 1 minus x squared. All right? Now, of course, you would want to rationalize that by multiplying both the numerator and the denominator by the square root of 1 minus x squared. Up top, I would get the square root of 1 minus x squared. Down below, I would get 1 minus x squared. And there is your simplification of that answer. Okay? All right, I believe we are done with our notes. If you have any questions, please email me, call me, show up in a Google Meet, whatever you need to do. But get in touch with me if you have any questions with your assignment. Have a good day. Thank you. Bye.